In today's thermochemistry lesson, we're going to learn about heats of formation. A heat of formation is the energy change observed when 1 mole of a compound is formed from its component elements at their standard state, which is 1 atmosphere and 25 degrees Celsius, so essentially room conditions. So you can use these values to calculate the energies for reactions by subtracting the enthalpy of formation of the reactants from the enthalpy of formation for the product. So if we're analyzing this reaction, the combustion of propane, the components involved are you have propane, you have oxygen gas, carbon dioxide, and water. So I'm just showing down here the enthalpy of formation reactions for each of those things. So for propane, carbon dioxide, and water. Just showing you that propane is made up of carbon and hydrogen. Carbon's a solid at standard conditions, so hydrogen's a gas, propane's a gas. Carbon plus oxygen makes carbon dioxide, and hydrogen plus oxygen gives you water, and water is a liquid at 25 degrees Celsius. So these are the energy changes associated with the formation of each of these from their component elements. Now using those, we can calculate the overall heat of our reaction by subtracting the heat of formation of the reactants from the heat of formation of the product. This right here just means the sum of, so we're going to add up the heats of formations of the product and then subtract the reactants from it. Plugging those values in from our previous work, you can see that you have 3 carbon dioxides in the process. So you would multiply the negative 393.5 kilojoules by 3. You have 4 waters being produced. So you multiply the enthalpy of formation of water by 4. Adding those up, we get down to here, and that's the energy change from the heats of formation of our products. For the reactants, the only thing we have to look at is the propane, which has the enthalpy of formation of negative 104. Since we only have one of them, that's pretty easy to do the math for. Oxygen does not have a heat of formation because to form oxygen from its component elements of oxygen, there's no energy change. So subtracting the 104 from our enthalpies of formation of our products, we get the overall heat of the reaction to be negative 222.0.5 kilojoules for the combustion of a mole of propane.